All right, hi everybody. Today we're going to be talking about atoms and molecules. We're not going to spend a whole lot of time talking about it because this is stuff that should be covered either in junior high or again in chemistry. But in order to do a biochemistry unit, we need to know some things about things like atoms and molecules. So I just want to refresh your memory. First of all, what you're looking at is called the periodic table of the elements. An element is anything in nature that cannot be broken down into simpler kinds of matter, and there's more than 100 of them that exist. And you would recognize ones like hydrogen and nitrogen and carbon. Those are the elements. Fewer than 30 of them are important to life. So what exactly is an atom? What counts as an atom? Well, an atom, whoops, trying to get my picture out of the way. An atom is the smallest unit of an element having all the characteristics of that element. I always thought that was a super confusing term or definition, but basically atoms have a nucleus and then they have electrons that orbit around the nucleus. So the electrons are negatively charged and they have almost no mass. They're moving in like the speed of light. They're moving incredibly, incredibly fast. Then the nucleus, and this diagram is so flawed. The nucleus is so incredibly small that you would not be able to see it on this page. But the nucleus includes protons, and the protons are positively charged, and they have a mass of 1. We call it 1 atomic mass unit. So when we're adding up how heavy an atom is, or what the mass of an atom is, we add the protons to the neutrons because the electrons basically have no mass. They're so incredibly tiny. So neutrons are neutrally charged, which means they don't have a charge, and they have a mass of 1. So one more time, electrons, no mass, but they're negatively charged. Protons, a mass of 1, and they're positively charged. Neutrons, no charge, but they also have a mass of 1. So the mass of an atom comes from the nucleus where the protons and neutrons are added together. So this one says label the parts of the diagram using the terms proton, neutron, and electron. So this arrow is pointing to an electron, so you would label it thusly. And all these little things on the outside, those are the electrons. And then I don't know which one comes next. There we go. The positive one is the proton. And then the one that doesn't have any symbol on it at all, those are the neutrons. Any questions? I can't answer them if there are, so moving on. All right, now what is a molecule? A molecule is 2 or more atoms put together. So you think of molecules like water would be an example. H2, it's got 2 hydrogens and an oxygen. That's an example of a molecule. Glucose, which is a type of sugar. Carbon dioxide, caffeine. Those are testosterone and estrogen. Those are hormones that are molecules. So this is a molecule of caffeine, a model of caffeine. Each of the little balls represents 1 atom. So the black ones are carbon. The blue ones, I have to think about that for just a second. Those are oxygens. The white ones are hydrogens, and I'm not sure what the red ones are. I'm not entirely sure what this is, how this diagram is working. But the colors tell us which element. I just don't know on this particular diagram what they are. All right, so let's talk about the most common biological bonds in nature. So we're studying biochemistry. So we're talking about the chemistry of life. What are the most important elements? So there's 4 elements that we really need to be solid on. Hydrogen, and hydrogen makes 1 bond. So that's what that single line coming out from the hydrogen is. That means it makes 1 bond. Oxygen has 2 lines coming out from it. So that means it can bond with up to 2 other atoms. And so it's got 2 bonds coming out of it. Nitrogen is able to bond with up to 3 elements, and carbon is able to bond with up to 4 elements. 96% of all living matter is composed of those 4 elements: hydrogen, oxygen, nitrogen, and carbon. I want you to know those 4 elements, so we give you this dumb word to help you remember them. The word is just HONC: hydrogen, oxygen, nitrogen, carbon, HONC. And what's convenient about the word HONC is that also tells you how many bonds each one makes. Hydrogen makes 1, oxygen makes 2, nitrogen makes 3, and carbon makes 4. HONC. Those are the letters in the word itself. So those are the 4 that you really need to know. All right, almost done. This is a quick set of notes, everybody. We just need to make sure we understand about water, and hopefully this is review for you. Water is made of 2 hydrogens and 1 oxygen. So down below, these white balls, those are the hydrogens in this case, and then the red one is an oxygen. So oxygen is slightly negative, and each hydrogen is slightly positive, and that's really important because that means they're attracted to each other. So the oxygen of one molecule attracts the hydrogens of a different water molecule, and we call that a hydrogen bond. But hydrogen bonds are incredibly important on this planet, and they really are what allow life on this planet. There's many things that are important to allowing life on this planet, but hydrogen bonds in between water molecules are really key. Hydrogen bonds are what cause ice to expand and then float on top of water. If it weren't for hydrogen bonds, they would sink down, and ice would sink down, and our oceans and our ponds and our lakes would freeze solid. There's countless other explanations of where hydrogen bonding between water molecules is important for life. So that's it. Let me know if you have any other questions. Go ahead and fill out the note sheet and turn it in. Thanks.